Okay, now so in this type of question you can use any method that you wish to use, whether it is uh, substitution method or elimination method. But if you look at this compared to the previous ones we've seen early on during this lecture, you see that we have two equality signs. So is this equals to this equals to this. Now how do we go about questions like this? Now let me explain something. Let's say we have three individuals. So let's say at this age is equals to 10. It's 10 years. At this age is 10 years. And Wale's age is 10 years. Now what this mean, the interpretation of this, we can also say at this age is equals to Wale's age. You can simply put it like that. Since Ade's age is 10, Wale's age is 10, so we can conclude by saying Ade's age equals Wale's age. So you can write it like this. You can say Ade's age equals Wale's age and is equals to 10 years. So that's the interpretation. That's the kind of interpretation. So still leaving this on the board, I'm going to manage it. So we can just say this equals to this and this equals to this. You can use it anyhow. You can say this equals to this equals to this, anyhow you want to do it, since they are all equal to each other. So you can say this equals to this and this equals to this, just like Ade's age equals Wale's age and Wale's age equals 10 years. So that means Ade's age is also 10 years. So you can put it anyhow. So for simplicity, let me just do it like this. So I'll just rub this up. If you don't get that, you can pause the video, go over it again, just for you to understand. So using that illustration, I'll just say this equals to this. So 2x minus 3y plus 10 equals to 10x minus 6y, and 10x minus 6y equals to 5. Now to make it look conventional, so I'll bring out what I need. To make this look conventional, I'll just try and make the x and y to be on the left hand side and the one that does not have x to be on the right hand side. This one looks perfect. There's x and y on this side already, so with this one that we'll do something about. So we'll take all the x and y here, we'll bring them here, then this one goes to that side. So if we do that, focusing on this, so we already have 2x. So if we bring this 10x to this side to come and meet this 2x, we have minus 10x, because originally it was plus. Then there is minus 3y. Then if we bring minus 6y to this side, it becomes plus 6y is equals to, if this plus 10 goes to that side, becomes minus 10. So now is making sense a little bit. So but let's get rid of, let's make sure we have just one x. We have 2x, 10x, 3y, 6y. So let's just make sure we have x with one coefficient, y with one coefficient. That will make sense. So 2x, there is a plus, invisible plus. You have 2x, but you are owing somebody 10x. You have 2x, but you are owing somebody 10x. Now if you try to pay all the 10 that you are owing, it will be impossible. You can only pay 2 out of that 10 and you still be owing 8. You have minus 8x. Then this is minus 3y plus 6y. You are owing 3y, but you have 6y. You have more than what you are owing. So if you are not stingy, you can pay everything. So if you try to pay all the 3y, which you should do, you still have 3y left. So that's why this is plus 3y. You have minus 10. So let's say this is equation 1. Then this other one is perfect. So you have 10x minus 6y is equals to 5. Now I would like to use the elimination method here. So let's say I want to eliminate y. Now you can see why it's good to find LCM. The bottom line is to make them have the same coefficients. Now if I take this 3 here and I take this 6 to that side, 6 times 3 will give me 18. 3 times 6 will give me 18. They are the same, but the values are large. We have problems because this one will be large. 6 times 8 large, 3 times 10 30, large values. So instead of doing that, why don't we just find the LCM of the coefficients we want to eliminate? We have 3, we have 6, so let's use 3. 3 in 3, that's 1. 3 in 6, that's 2. Then let's use 2. You write 1. 2 in 1 is 1. 2 in 2, 1. So the LCM is 3 times 2, that's 6. Not large, 6. Perfect. So you now ask yourself, so let's not use that other method. You just ask yourself, what will you multiply by this 3 to give us 6? That's 2. So this is 2. And what will you multiply by this 6 to still give you 6? Is 1. So you can see why I prefer this method. You find the LCM of the coefficient that you want to eliminate. Then you find a way of turning the coefficient of those variables to that LCM. So that's how we do it. So now we are multiplying. So 2 times minus 8, that's minus 16x, plus 2 times 3, that's 6y, is equals to 2 times minus 10, that's minus 20. So we use the 2 to multiply everything. Then you use this one to multiply everything. 1 times 10, that's 10x. 1 times minus 6y, that's minus 6y. Then 1 times 5, that's 5. Now the coefficients are the same. Then you check the signs. The signs are different. Yes, perfect. The signs are different. The ones we've been doing, the signs are the same. But this time around, the signs are different. And I told you, if the signs are different, to eliminate, we would add. So since the signs of what we want to eliminate, they are different, that means we are going to add both equations. So how do we add? So this is minus 16x plus 10x. So you are owing 16x, but you have 10x. You are owing somebody 16x, but you have 10x. So if you try to pay all the 16, it will be impossible because you have less. What you have is less than what you are owing. So if you try to pay, you'll still be owing 6. So because you'll still be owing, we'll say this is minus 6x. Then what about this? This is plus 6y plus minus 6y. So the signs are close to each other here. So you use plus times minus, which is minus. Now what you are owing is equals to what you have. You are owing 6y and you have 6y. So if you pay everything that you are owing, which is the normal thing, you have 0. So this will be plus 0. You can use plus 0 or minus 0. It does not matter. 0 is a neutral number, so it will not really have effect whether you are adding or you are subtracting. Then this one is minus 20 plus, there is an invisible plus 5. So you are owing 20 but you have 5. You are owing somebody 20 but you have 5. So if you try to pay all the 20, it will be possible. So you still be owing 15. You put a minus. So we have minus 6x plus 0, that's minus 6x, is equals to minus 15. So if you divide both sides by minus 6, this cancels this. 3 can go in 6 2 times. 3 can go in 15 5 times. So x is 5 over 2. So we found x. Now the next thing is to look for y. So we can put the value of x into any of the equations. So we can say put x equals to 5 over 2 into, let's say, equation 1, into equation 1 to find y. You put x equals 5 over 2 into equation 1 to find y. So this is equation 1. So this is going to be minus 8. So anywhere we see x, we put 5 over 2. So this is 5 over 2 plus 3y is equals to minus 10. So now, I've seen students do this. Now if you are opening a bracket like this, there's a fraction inside and there's a whole number. Now you don't use this 8 to multiply everything. This minus 8 is the same thing as 8 over 1. So the numerator will multiply numerator, denominator will multiply denominator. Please take note of that important fact. Anytime you are multiplying a fraction and the fraction is inside the bracket, you should make sure numerator multiply numerator, denominator multiplies denominator. So minus 8 times 5 is minus 40. 1 times 2, that's 2, plus 3y is equals to minus 10. So 2 can go in 40, 20 times. So we have minus 20 plus 3y is equals to minus 10. So if this goes to that side, becomes plus. So you have minus 10 plus 20. So you have 3y minus 10 plus 20. You are owing 10 but you have 20. So if you try to pay all the 10, you still have 10. So you divide both sides by 3. So y is 10 over 3. So therefore, when x is 5 over 2, y is 10 over 3.